In this section, we'll talk about complex fractions. A complex fraction is one that contains fractions within its numerator and denominator, a fraction within a fraction. To simplify them, it's actually easier than it looks. You can just write the fraction as a division. So the numerator divided by the denominator. Make sure that you use parentheses for grouping the numerator and denominator together. Then perform the operations in the numerator. So we're going to give those two fractions a common denominator. So that would be 10/15 minus 2/15. And that gives us a result for the numerator of 8/15. And then we're going to perform the operations in the denominator. So we're going to give 1/5 and 2 a common denominator, so that 2 will become 10/5. And then that's divided by 11/5. Now all we have to do is change that division into multiplication. Cancel some common factors, so I'm grabbing my cancellation pen. And then multiply. And we've got 8/33. Let's try that in B. And so this is going to be 1/4 plus 2/3 divided by 2 minus 7/6. So we'll give those fractions in the numerator a common denominator, so 3/12 plus 8/12. And that's going to give us a total of 11/12 divided by, now let's perform the operations in the denominator. That's going to be 12/6 minus 7/6 is 5/6. So now all we have to do is invert that second fraction and change to multiplication, because division is multiplication by the reciprocal. Looks like we have some common factors to cancel here as well. That'll leave us a 2 in the denominator, and that gives us 11/10. All right, now it's your turn to try A below, so pause the video. All right, you should have gotten 1/2 for that one. Now try B. And that one should give us 1/14. All right, now let's do an example with variable expressions in it. So we have 1 plus 2 over x divided by x plus 2. So we need a common denominator, and that's going to be x. So x over x plus 2 over x, which gives us x plus 2 over x. I'll bring down the divided by, and that's x plus 2. And so now we're going to change that division into multiplication by the reciprocal. And look at that, we've got common factors. So I'm going to get my cancellation pen. We can cancel those out. Go ahead and do the multiplication. Gives us 1 over x. All right, similar for B. We have 2 over n minus 1 divided by 1 over 3n plus 5. For the numerator, we're going to go on the common denominator of n, so that's 2 over n minus n over n, which gives us 2 minus n over n. Bring down the divided by. And for the stuff in the denominator, we're going to want to get a common denominator for those, and that common denominator will be 3n. So that's 15n over 3n, which give us 5, right, if we did the division. And so now we have 1 plus 15n over 3n. Let's change that to a multiplication by the reciprocal. Grab that handy-dandy cancellation pen. I'm going to cancel those n factors, and that's just going to leave us with 3 times 2 minus n over 1 plus 15n is our result. Your turn to try. Try A. That one should give us 3c minus 1 over 2c plus 5. Now try B. We didn't have any common factors to cancel on this one, so we got 3 minus c over 3c times c plus 5. All right, let's do another example here. And in example 3, we have 1 over x minus 1 over 7. So we'll put that in parentheses, divided by the quantity x minus 7. Okay, we're going to give those common denominators of 7x. So 7 over 7x and x over 7x. So 7 minus x over 7x. And we're going to divide that by x minus 7, which is the same thing as multiplying it by 1 over x minus 7. Now, you may remember we talked a little bit in multiplication of fractions about the fact that 7 minus x is actually the same thing as negative x plus 7 if you change the order of the terms. And you can factor out a negative 1 and it'll leave you with x minus 7. So if we cancel these factors, they're actually opposite factors, going to leave you with negative 1. So now multiplying through, we get a result of negative 1 over 7x, or negative 1 over 7x. In b, we can do the same thing, 1 over a plus 1 over b, divided by a over b minus b over a. All right, so in the numerator, it looks like our common denominator is going to be ab. So that will be b over ab plus a over ab. And that means the numerator simplifies to b plus a over a times b. And then divided by, and we'll have a common denominator here of ab as well. ba, same thing, but I'm just going to write it in alpha order. All right, and so that means that that first fraction got multiplied by a over a. So that's going to give us a squared in the numerator and b squared in the numerator. So when we rewrite this one, it's a squared minus b squared over ab. Now we need to invert the second fraction and change to multiplication. And at the same time, we can also factor, oops, and somewhere along the line I wrote that denominator of the first fraction wrong. That was a times b. And the second fraction's denominator factors into a plus b times a minus b. So we can cancel the a plus b's. B plus a and a plus b are the same thing. Oh, and we can also cancel the a's and the b factors in those numerators and denominators. That's just going to leave us with 1 over a minus b. All right, your turn to try. Try a. This one should have a result of negative 1 over cd times c plus d. Again, we have the binomial subtractions that are reversed order. Those are opposites, right? So when we cancel them, we get negative 1. Now try b. There is the result for b. And now, let's see what other exciting things we have to do. Okay, so these are getting a little bit more complex as we go. In example 4a, we have 4 over a minus 5 minus 2. Let's just go ahead and get a common denominator right now. So we're going to make this 2 times a minus 5 over a minus 5. And that's all the numerator. And then that's divided by what's in the denominator. And we'll do the same with it. 3 times a minus 5 over a minus 5 minus 6 over a minus 5. So just go ahead and get the common denominator to start with. All right, when we perform the operations in the first bracket, we have 4 minus 2a plus 5. Remember, when you're subtracting and distributing, maybe remember to distribute the minus sign as well. That fraction is going to give me negative 2a plus 9 over a minus 5. All right, now let's work on the denominator part. This one's a little bit easier because the subtracted fraction only has a single term in the numerator. So we've got 3a minus 15 minus an extra 6 all over a minus 5. In the next step, let's go ahead and change this to multiplication and invert the second fraction. So we'll have an a minus 5 on top, and then on the bottom we have 3a minus 15 minus 6, which is 3a minus 21. Now our a minus 5s can cancel. 3a minus 21 could factor into 3 times a minus 7, but the 2a minus 9 is not going to factor, so I don't think we can reduce this. So I'm just going to leave my result as negative 2a plus 9 over 3a minus 21. You can factor that denominator if you want, but it's not necessary. And let's try this next one. So this has a single fraction in the numerator, so I don't really need to do anything with it. But we do need to do stuff with the denominator part. So we're going to have a common denominator of 2a. So that's 2 over 2a plus a over 2a. So that's divided by a plus 2 over 2a. You can write it 2 plus a if you want. I just switched it. And so I'm just going to bring down our first fraction. And then we have to invert. Before you get the idea that we should cancel here, you may only cancel common factors once we've changed it to multiplication. So this is 1 over a plus 2 times 2 over a times a plus 2 multiplying through 2a over a plus 2 squared is our result. All right, your turn to try a couple more before we call it a day with complex fractions, and try a. All right, this one should have given you negative 1 over 5 times x plus 2. Be super, super careful here when you're subtracting those first couple of fractions. If there's a binomial in the second fraction, we have to change it to the opposite of each term. So the opposite of x is minus x, and the opposite of 2 is minus 2. And that's going to give us our result. All right, now try b. All right, this one should give us the opposite of a plus 3 over 9a. And that's it for complex fractions. Now you can do the practice for that section.